Okay, just a second. Hey guys, can you hear me? Right? Okay. Yeah. So, are you ready? Okay. First, I would like to talk about the gadgets I have here. I have two Firefox OS phones running the latest version of Firefox OS. Now you might say that Firefox OS is dead. Yeah, and you might be true, but come on, the web is not gonna die. So these are basically web platforms. What else I have here is a virtual reality cardboard. What you can try it out at Mozilla booth I'm running there. So basically, after my presentation, you can try it out. I will give you a few stickers, and we can talk about Firefox OS or WebRTC. So I'm going to talk about today about WebRTC basics, about WebRTC API, about the browser support, and I have two demos to show you. And what I didn't mention that I have a Raspberry Pi here running my own personal hotspot to show you the demos. Okay. So about me, uh, I work and live in Budapest, Hungary. I work as a front-end developer for Dockler Holding. You might have heard of Dockler Holding because we have worldwide popular live streaming websites with adult content too. I'm volunteer at Mozilla for like 3 years now, and I do a bit of public speaking, and I participated the Mozilla Tech Speaker program, which is about public speaking. You can see my Twitter and Facebook account down below. I often tweet about WebRTC. So, in May 2011, Google released this open source project. It's basically a browser-based real-time communication. WebRTC provides browsers and mobile applications with real-time communication capabilities. Web real-time communication is an API that supports browser-to-browser applications for voice calling, video chat, and peer-to-peer file sharing. Of course, you don't have to install internal or external plugins in order to use that. The connection is meant to be rich and high quality. WebRTC can be used in desktop browsers, mobile platforms, or IoT devices. It uses mainly UDP as a network communication method. I said mainly because it sometimes there are cases where it falls back to TCP. The connection is secured by DTLS. It is basically a security solution for datagram protocols, as UDP is. So next, I'm gonna show you a WebRTC demo. Okay. Let me start it. Just a second, please. Okay. Now you can probably see what I see. Okay. Okay. So this application is a room-based application. User can enter the rooms, and the participants can initiate the connection between each others. So I would like to ask somebody from the audience to pick one of the Firefox OS phones, and let's try out with somebody. So, who is brave enough? Okay, then I'm gonna... Just a second. So you have this WebRTC application. You just type in the room name and create a room. I suggest you to like a RSCONF. Yeah, let's try it. Create a room. Okay. You were asked to give a permission to back camera. Front camera, yes, share. And you are ready? Wait a second. Now I'm gonna join the RSCONF room too. It says I have to share the hardware. I'm gonna share it. And here we go. So basically this is running from two browsers. They are connected to each other. Thank you so much. And of course, I don't want to forget about special stickers for you.
Thank you very much.
Okay, let me switch back. Okay, I'm gonna drink a bit. Okay, so that was amazing, right? Yeah, it looks simple. Okay, so who uses WebRTC now? With a blue background, there are companies who are using WebRTC and they have more than 10 million active users, like Facebook, Hangout, and WhatsApp. Of course, not only these companies are using WebRTC, but you can find better statistics from Google because they are tracking the usage of WebRTC API. So whenever someone calls the WebRTC API from Chrome, they know about it. There are other applications like Firefox Hello or Appian or Talkie.io you might have heard of, and you might using it. So let's jump to the support slide. You can see most of the browsers support WebRTC except Safari. There are rumors there were rumors on the internet about Apple that they will land the WebRTC or few features of WebRTC in early 2016, but they didn't. We don't really know that if they are planning to support WebRTC or not. We know that they have spent a lot of money building FaceTime, so that's probably the reason why they didn't implement it yet. Microsoft Edge does support ORTC, which is another newer version of WebRTC, but I will talk about it later. As you can see, it is almost the same for mobile devices. Android, Chrome, Opera does support it. There is no support for Safari at all. So, I said there is no browser support, but there is another solution for iOS and Mac OS X. You can build native apps that communicate with the browser that supports WebRTC. It is focused on mobile platforms, free to use and open source. It is available on GitHub. Feel free to contribute. It has cross-platform support for iOS, Mac OS X and Android, and they are aiming to support Windows too. So let's contribute. I'm gonna show you how you can build WebRTC applications with a step-by-step tutorial. I hope we will have time for that. But before, you have to understand the basic pillars of WebRTC. So let's continue with that one. Session description protocol dates back to 90s. Many real-time communication software have been using it. It is basically a stream-based business card of your computer, which contains audio and video support details, network lookup, how much of your computer can handle. One of the reasons WebRTC uses FDP is that it needs to be easy to transport, because your computer business card will be shared with another peer and vice versa. Next, what you should know about is WebRTC API. It consists of three main functions. The first is get user media. After calling it, a small window will be prompted up, as you have seen, and it means the user has to accept that, and after, the camera and microphone might be shared. So the get user media allows a web browser to access the camera and the microphone. RTC peer connection does the magic for you. Basically, it sets up audio and video calls. RTC data channel will help you to share data peer-to-peer. Okay, now what is Stun? Stun is a service which will help you detect the client's IP address. If the connection between two peers cannot be established, turn server will be used as a relay between two clients. This can happen due to strict firewall or some different network issues. As candidates provide information about where the data is going to be exchanged, I mean IP address and port. The more candidates you have, the better the situation is. So, how you can establish the connection? You can see there are two persons, they want to connect to each other, but how? For negotiation, you need a signaling server. The signaling server is not the part of the WebRTC specs. You can do it anyhow you want. I always do it with WebSockets, but you can use Ajax, or either you can use your floppy disk and give your friend. So the peer have to log into signaling server to let each other know they are online. Oh, it's a bit down, okay. That's all. So as soon as they know who is online, as a first step, to one of the clients have to create an offer. I hope you can see it well. So this offer goes through the signaling server, and the other client receives it. Once the offer is created, ICE candidates will be generated with the help of the Stun server. The other clients has to create an answer for that offer, but before the candidates will be shared over signaling too. So when it's done, it needs to be sent back over the signaling, I mean the offer, the answer, and the first client will receive an answer. So you can imagine that you come to a conference, you have your business card, other person have a business card, and you exchange that business card, and let's see what you can deal together. After the answer is created, another peer goes to Stun. It asks for the candidates, and it shares back with the use of signaling server. So the peer-to-peer connection can be established. Okay. Wow. So, just to underscore that, signaling server is for sharing RTC peer connections offer, RTC peer connection answer, and ICE candidates. So, let's code. You know the basics, and we can code. What I have to do. Okay, this is still running. Okay. Okay. So there is this tutorial I made for you to understand how these steps are done. What it does, it's basically picks my video and sends it to another other client. So the first, I will show you the first code snippet. It is here. So I'm gonna type in navigator .media devices.get user media, which returns a promise stream from the hardware. So let's do it. Okay, now I'm twice in one presentation. That's great. Then you have to create a peer connection. Here you can see a few configs. I'm defining the peer connection configuration. You can put stun and turn config here. After, you have to define a few constraints, and then you create your own peer connection. With, of course, you have to apply these configurations and constraints. And then set the ICE candidate listener and set the remote stream listener. So when the other client will receive my stream, it's he's gonna append it to the video element tag. Let's do it. It's okay. As a next step, I'm gonna add my stream to that peer connection. So, as I told you, one of the clients has to create the offer. Here are the constraints. That's okay. And let's create an offer. And the offer returns the SDP, which I mentioned. Okay, let's do it. Here you can see the offer which is created. Then I have to send the SDP offer to the other client, but I don't have a signaling server, so I'm gonna copy it and paste it here. So I'm gonna act like a signaling server. So the other client received the offer for a video call. You have to create a remote. You have to create an instance of RTC session description. Then you set that offer to as a remote description. So remote description has been initiated. Then, as I told you, you have to share the ICE candidates. The ICE candidates, I have few here. I'm gonna copy it. and send the ICE candidates. I thought there is no signaling server, so I'm gonna paste it down here. Okay. So new RTC ICE candidate has been created and added to the peer connection on the remote side. So let's create an answer for that offer. So you can see the browser created an answer for that offer. And then I set the answer on the remote as a local description. As a next step, I send back the answer to the first participant. There are of course various solutions for that. So let's act like a signaling again. Let's paste it, and the RTC session description is created, and then I set the remote description on local, and if everything worked, I will be here 2 times. Yeah. So you can see how the WebRTC connection is gonna be is established. So I'm gonna close this connection. Okay, I smiled because it took a selfie. Nice. Okay, let's go back. Mirror. Okay. Okay. So, was it like that? So you might think it's difficult, and maybe you are right, but feel free to talk to me, and I will try to explain it if it wasn't clear. So if you don't want to mess with different WebRTC implementations, you should use adapter.js. It is a polyfill for WebRTC available on GitHub. So you might use it if you want to support more than one browser. Now I would like to show you really good use cases for WebRTC file sharing feature. You might have heard of the new generation of BitTorrent for the web. It is called WebTorrent. So imagine peer-to-peer YouTube where viewers have to host the site's content. Or imagine there's a file on the server which we would like to download. I'm gonna download a little bit of the file, and you are gonna download the rest. And then we going to exchange the pieces of that file. Does that make sense? Okay. So you might remember this recently launched game from Google, where you could use your smartphone as a server. So it was built using WebRTC, exactly the peer connection feature. This library was created for the same reason, where you can connect your input devices from your desktop to your mobile phone with WebRTC. It comes handy when you are building WebVR, so check it out. If you would like to put server between 2 peers, for example, for recording audio or video, you can use these solutions down below. I have actually seen a really beautiful talk at FOSDEM in Brussels about Janus. It's a really useful tool, as you can use it as a gateway. There is this project called Alliance for Open Media, This is a project for focusing on creating a new audio, new media format, because they are saying it's enough. Let's go to open standard, which works on the web and fits any modem and bandwidth. And it's capable of streaming high quality real-time video. This is great for WebRTC. You can see the contributors below: Mozilla, Google, Microsoft. I told you a bit about WebRTC. It is a free and open source project that enables mobile endpoints to talk to server and browsers with RTC capabilities. It is often called WebRTC 1.1. It is a low-level API. Google, Microsoft, Hookflash has been working on it. So there are a few news I want to mention today. One amazing feature of WebRTC, at least in my opinion, is that you can use Canvas as the source of your stream. So you might want to put 2 videos or 2 streams to that canvas. You might want to draw on that canvas. So you can use that canvas as the stream. So the canvas will be shared with another client as a stream. The other great implementation is screen sharing. Unfortunately, you can use it now only with a few restrictions. Simulcast support means that the user is sending who is sending a stream in different solutions, so the server don't have to scale that stream, or don't have to do other things with it. And there are improvements in audio quality as well. Is WebRTC ready yet? And that's a great question. You can check the current state of WebRTC for different browsers and different features if you go to iswebrtcreadyyet.com. WebRTC.org is the main website where you can find demos, tutorials, and everything else. It's by Google. WebRTC Weekly is a newsletter where you can subscribe on. They are sending you weekly news about WebRTC. So, thank you so much for paying attention. If you have few questions, I might answer them.
Thank you very much, and I've got a few questions. So the demo you tested first in Firefox on mobile phones. Does it actually works in mobile phones in Chrome?
Yeah, on Android it works.
And what about iPhone? Does it work there? Because I tested and it didn't work.
Yeah, it might not. So in Apple is in something new dimensions or other dimensions. They are not really supporting WebRTC, as I thought. So I think it's not working on iOS.
So is it actually supported when I use some libraries? For example, you
yes. If you would like to write native apps, you can use that by that project OpenWebRTC.
So native apps, not browser.
Native. Basically, it uses somehow the browser for doing that. I don't really know how, but it is useful.
So actually, in our company, we use RTC in browser, and now we are writing an application in desktop in Java, like using JavaFX. And is it actually possible to use some libraries from Google who can give me support for Java, not using WebView, I mean browser, in my native Java application for desktop?
I don't really know the question to answer the question, because I'm not friendly with Java or Java, so I don't know any libraries for that, for Java. unfortunately.
Thank you. Perhaps one more question.
You're welcome.
And the demo you showed earlier, just for test, is it actually available somewhere in the internet, not only from your computer?
Well, I
have
built
some
it
link?
for the conference purpose. So maybe I put it out to GitHub.
It will be great. Thank you.
Okay.
Thank you. Thank you very much.
Thank you. Are there other questions?
Hi again, Gabriel.
Hi.
Thank you for the talk. So I have a small question regarding WebRTC. So
Okay.
as far as I understand, it's something that goes peer-to-peer. So
Yeah.
it's direct communication between
Yeah,
two different browsers. I do understand there is a need for this signaling server in order for the peers to find themselves. But what is the need for those tongue servers and ICE candidates? I mean, once you go to this server, they find each other, they understand their IPs, and they could connect directly. Why? What is the need for those additional servers, like tongue server, ICE candidates, as far as I remember?
Well, ICE candidates are generated by RTC peer connection with the help of the stun server. So stun you need for detecting your IP address when you go to what's my IP address.com. It basically does the same almost. And turn server is when the RTC connection tries to connect with each other, and when it fails, it goes to turn, and the turn is a relay. So you have one client, you have another, and at the top of that you have that turn server. So the connection goes like that.
Okay, so if I understood it correctly, the idea is that you have those additional servers in case you are not able to connect your devices directly. So if
exactly.
they're connected directly, you don't really need those servers, right?
Yeah, but you need stun, but turn you don't need if the network is great.
Okay, thank you.
Hello, one question about share screen.
Yes.
It works great on desktop browser, but what about mobile device? I want to share my screen and for support other side.
Okay. That's a good question. So in browser, it's currently you have. I'm gonna show you. You have to basically you need add-on for that.
Yeah,
But in mobile, I don't know.
Okay.
I'm sorry, but I can ask it from some guys. So we should talk later about that.
Great.
Okay.
Thank you.
Any other questions? I can hear it, and I will repeat it.
Well,
okay.
Gabriel, thank you for your speech. One little question.
Okay.
You demonstrated how it works between Firefox. One side used Firefox and another side used Firefox as well. The question is how well it works between Chrome and Firefox. Are there any incompatibilities or something?
Yeah.
I heard that
this is
there
why,
might be something wrong with that.
This is why I suggest you to use that polyfill library, because there are a bit difference between. When I showed you the constraints you have to apply, I'll go back and show you. How can I go there? Ah, okay. Not this one. Here it is. Yeah. Can you see these constraints here? One of the differences is that on Chrome, it's with a capital letter. and in Firefox it's different. This is one of the configurations. So this is one different I know about. But I built both apps without that framework, without that polyfill library. So I think this is the one difference. But I don't know anything about Opera because I did not test it.
Okay, and one additional question is that we in our company build an application which uses two simultaneous video streams. Like first stream is like from camera to camera, and the second stream is the mentioned screen sharing. And the problem we faced that we cannot transfer two simultaneous video streams between Firefox and Chrome. If someone decides to share their screen, we have to turn the camera off and show the screen. And otherwise, are there any ways you know to use?
Have you tried that Canvas solutions?
Actually, no.
No, you should try it.
Okay,
maybe you can put the Canvas, both of them. I mean the video camera stream and the screen of your computer on that canvas, and then you pick a canvas as a source element. So let's try it.
That might probably be a good idea. We'll definitely look at it and try it. Thank you.
Thank you. Any other questions?
Hi.
Hi.
So I have one more question about, is there some logical limit about peer-to-peer connection? So how many users I can connect direct?
So there is no limit, but of course there is a limit. The limit is the network. I suggest you to go up to six participants and no more. Then you might want to do that. You hide those who are not speaking, so you can. You might want to add more participants than 6. But if they don't speak, if they are not active participants, then you mute them and you don't share the stream. Does that make sense?
Thank you for talk. What is about security with connections and streams?
Okay, so you saw the DTLS I mentioned. The DTLS is a solution for security. So the connection between the WebRTC connection between two peers, it's encrypted by the help of DTLS. The data, what goes through the signaling server, you should take care of it. So for signaling, you might want to apply another encryption, but the signaling part is not the part of the WebRTC specs. So that's your job to make it secure. But it is encrypted.
Thank you.
So we have no more questions. Okay, so thank you so much again.
Well, in our conference, we not need to sleep inside the dead horse, like, and this is our small Oscar for you for being here and awesome talk.
Thank you so much.
Thank you.
Okay, thanks.
Перерыв 10 минут. Мы продолжим в 12:20.